For millennia, we humans have gazed up at the night sky in wonder. The twinkling stars, the pale band of the Milky Way, all whispered of mysteries waiting to be unraveled. And as we've journeyed deeper into the cosmos, we've uncovered truths stranger, more fantastical than any myth or legend. Did you know there's a planet made entirely of diamonds? That's just one of the insane facts about our universe that you're about to hear. And trust me, you won't believe number 7. So buckle up, fellow explorers, as we embark on a journey to the edge of knowledge and imagination to uncover 10 universe facts that sound fake but are true. Imagine a world so extravagant, so opulent, that it would make even the most decadent earthly treasures pale in comparison. A planet not just adorned with diamonds but entirely composed of them. It sounds like something out of a cosmic fairy tale, yet it's very real. This glittering world, known as 55 Cancri E, orbits a star some 40 light-years away in the constellation Cancer. Twice the size of our own planet and with 8 times the mass, 55 Cancri E whips around its host star at breakneck speed, completing an orbit in just 18 hours. But what truly sets this planet apart is its composition. You see, 55 Cancri E orbits a star that, unlike our own sun, is rich in carbon. And under the intense pressure and heat deep within the planet, these carbon atoms have bonded together to form a gigantic shimmering diamond. Astronomers estimate its value to be a staggering $26.9 nonillion. That's a 26 with 30 zeros after it. A king's ransom indeed. We've all heard that the speed of light is the ultimate cosmic speed limit, an unbreakable barrier. And while that's true within the fabric of space-time itself, the universe as a whole plays by slightly different rules. You see, the universe is expanding. And it's not just expanding, it's accelerating. This mind-boggling concept is known as cosmic inflation. Imagine a balloon with dots drawn all over it. As you inflate the balloon, the dots don't move on the surface, but the distance between them increases. Similarly, galaxies aren't flying through space. Space itself is stretching, carrying them along for the ride. And the rate of this expansion? It's happening faster than the speed of light. This doesn't contradict Einstein's theories because it's not motion through space but rather the expansion of space itself. This means that there are regions of the universe so distant from us that we'll never be able to see them, no matter how powerful our telescopes become. They are forever beyond our cosmic horizon. It's a humbling thought that reminds us of the vastness and mystery of the cosmos. Have you ever walked along a beach mesmerized by the countless grains of sand slipping through your fingers? It's a humbling experience, a reminder of the immensity of nature. But what if I told you that there are more stars in the observable universe than grains of sand on all the Earth's beaches combined? It seems impossible, almost ludicrous. Yet this mind-boggling fact is based on careful astronomical observations and calculations. There are estimated to be 100 billion trillion stars in the observable universe. That's a 1 followed by 22 zeros. To put that in perspective, let's do some back-of-the-envelope math. A typical grain of sand has a volume of about 0.009 cubic millimeters. The Earth's surface is about 510 million square kilometers. And let's generously assume a sand depth of 10 meters for all the beaches on Earth. Even with these generous assumptions, the number of grains of sand on all the Earth's beaches comes out to be a paltry 10 followed by 18 zeros. That's still an astronomical number, but it's dwarfed by the sheer number of stars twinkling in the cosmic expanse. Chapter 4. A day longer than a year. Time, as we experience it here on Earth, is governed by the steady rhythm of day and night, the cycle of our planet's rotation. But on Venus, our closest planetary neighbor, time dances to a different tune, a languid, almost surreal waltz. Imagine a world where a day is longer than a year. This is the reality on Venus, a planet shrouded in thick, swirling clouds of sulfuric acid. Venus rotates incredibly slowly, taking a leisurely 243 Earth days to complete a single rotation. In contrast, it zips around the Sun in a relatively brisk 225 Earth days. This means that a day on Venus, from sunrise to sunrise, is longer than its orbital period, a truly bizarre cosmic quirk. The reason for this sluggish rotation is still a mystery, though some scientists speculate that it might be due to a massive impact early in the planet's history. Whatever the cause, Venus stands as a stark reminder that our experience of time is but one of many possibilities in the vast tapestry of the cosmos. Chapter 5. A toast to the cosmic cloud. Imagine a cloud so vast, so laden with alcohol that it could quench the thirst of every beer lover on Earth for billions of years. While it might sound like the stuff of intergalactic pub crawls, this colossal cloud of alcohol is very real, drifting some 10,000 light-years away in the constellation Aquila. Discovered in 1995 by astronomers using radio telescopes, this cloud contains enough ethyl alcohol to make 400 trillion pints of beer. That's a 4 followed by 20 zeros. This cosmic cocktail is not the kind you'd want to drink, however. It also contains other molecules, some not so palatable, like carbon monoxide and ammonia. But the presence of such complex organic molecules in space has profound implications. It suggests that the building blocks of life, once thought to be unique to Earth, might be common throughout the universe. So, next time you raise a glass, take a moment to appreciate the vast, intoxicating wonders of the cosmos. Chapter 6. A teaspoon of star stuff. Imagine a substance so incredibly dense that a single teaspoon of it would weigh as much as all of humanity combined. That's over 7 billion people. This mind-boggling material isn't found in some science fiction writer's imagination, but in the heart of collapsed stars, known as neutron stars. These stellar remnants are born from the death throes of massive stars, stars much larger than our own sun. When such a star exhausts its nuclear fuel, it can no longer support itself against its own gravity, and it collapses in on itself, compressing its core with unimaginable force. The result is a neutron star, a sphere only about 12 miles across, but containing more mass than our sun. The atoms themselves are crushed, their protons and electrons forced to combine into neutrons, packed together with almost no space between them. This makes neutron stars incredibly dense. To give you an idea, if you could somehow scoop up a teaspoonful of neutron star material, it would weigh about 6 billion tons, roughly equivalent to Mount Everest. Chapter 7. A Cosmic Oasis. Water, the elixir of life, is more than just an earthly phenomenon. In the vast expanse of space, astronomers have discovered a reservoir of water so colossal that it dwarfs all the oceans on our planet combined. This celestial oasis, a gigantic cloud of water vapor, lies some 12 billion light-years away, surrounding a supermassive black hole called a quasar. Quasars are among the most energetic objects in the universe, powered by supermassive black holes at their centers, greedily devouring matter and spewing out immense amounts of energy. The water vapor cloud surrounding this particular quasar contains an estimated 140 trillion times the amount of water in all the Earth's oceans. This discovery has profound implications for our understanding of the universe. It suggests that water, a key ingredient for life as we know it, might be abundant throughout the cosmos, even in the most unexpected of places. Perhaps somewhere out there, other water worlds teeming with life are gazing up at their own cosmic oases. We often think of space as a cold, desolate void, and indeed it is. But within this cosmic freezer, there exists a place so unimaginably cold that it makes the most frigid earthly temperatures seem balmy by comparison. This cosmic icebox is the Boomerang Nebula, located some 5,000 light-years away in the constellation Centaurus. At a chilling minus 458 degrees Fahrenheit, or just 1 degree above absolute zero, the Boomerang Nebula is the coldest known natural place in the universe. To put that in perspective, absolute zero is the theoretical point at which all molecular motion ceases. The Boomerang Nebula owes its extreme chill to a dying star at its center. As this star sheds its outer layers of gas and dust, it does so at incredible speeds, causing the material to expand rapidly and cool dramatically. This rapid expansion is like a cosmic refrigerator, drawing heat away from the nebula and plunging it to temperatures that approach the theoretical limit of coldness. Black holes, those enigmatic cosmic monsters, are regions of space-time where gravity is so strong that nothing, not even light, can escape their clutches. But what would happen if you got too close to one of these gravitational behemoths? You might imagine being crushed into oblivion, but the reality is even stranger. You would be spaghettified. Spaghettification is a rather gruesome but accurate term for what happens to an object as it falls into a black hole. Because the gravitational pull of a black hole is so intense and varies so greatly over short distances, different parts of your body would experience vastly different gravitational forces. Imagine falling feet first towards a black hole. Your feet, being closer to the black hole, would experience a much stronger gravitational pull than your head. This difference in gravitational force would stretch your body, like cosmic spaghetti, elongating it towards the black hole's singularity. As you fell further, the difference in gravitational force between your head and feet would become more and more extreme, stretching you further and further until you were ripped apart into a stream of subatomic particles spiraling towards the point of no return. When we gaze up at the night sky, we are looking back in time. The light from distant stars and galaxies takes time to reach us, so we are seeing these objects as they were in the distant past. But how far back can we see? What are the limits of our cosmic vision? The answer is both awe-inspiring and humbling: the observable universe. The observable universe is a sphere with Earth at its center, encompassing all the regions of space from which light has had time to reach us since the Big Bang some 13.8 billion years ago. The diameter of this sphere is a mind-boggling 93 billion light-years. To put that in perspective, if you could travel at the speed of light, it would take you 93 billion years to cross from one side of the observable universe to the other. But here's the kicker: the observable universe is just a tiny fraction of the entire universe, which might be infinite in extent. We have no way of knowing what lies beyond the cosmic horizon, the boundary beyond which we cannot see. It's a tantalizing thought, a reminder that for all our explorations, we have barely scratched the surface of the cosmic ocean. From diamond planets to cosmic spaghetti, from clouds of alcohol to the coldest place in the universe, we've journeyed through the cosmos, uncovering truths stranger than fiction. But perhaps the most remarkable fact of all is that we, humans, have been able to unravel these cosmic mysteries using the power of our minds and the ingenuity of our instruments. As we continue to explore, to push the boundaries of knowledge, we can be sure that the universe will continue to surprise us, to challenge our assumptions, and to inspire us with its beauty and its grandeur. So keep looking up, keep asking questions, and never lose your sense of wonder. For the cosmos is vast, and our journey of discovery has only just begun.